Hello, chemists. My name is Kim, and in this video, we are just going to do a ton of practice problems that have to do with potential energy diagrams. They're going to be Regents-style questions, but some of them will be extensions or a little bit different from actual Regents questions, and some of them will be exactly like the Regents exam. Here are the learning goals that these practice questions will ultimately be assessing. So take a moment to read through these learning goals. They should be familiar to you from videos that you have already watched. And we will go ahead and get started with our questions. Get ready, because we are about to do a bunch of practice problems. Which statement correctly describes an endothermic chemical reaction? Do the products have a higher potential energy than the reactants, and is delta H negative? Or is it the opposite? Do products have a lower potential energy and delta H is positive? So take a moment to read each option, think about what we just learned, and see if you can choose an option. I'm going to go over the answer now, so please pause the video if you haven't picked an answer yet. So remember, an endothermic reaction is a chemical reaction where energy is being transferred into the system. So reactants are absorbing energy to become products. This means that products should have a higher potential energy than the reactants, which means that delta H should be positive because the reactants gain energy to become products. So the answer would be option number 2. Take a look at this potential energy diagram and think to yourself, is the forward reaction moving from left to right a endothermic or an exothermic reaction, and why? So take a moment to think to yourself. In about 5 seconds, I'm going to start going over the answer. So pause the video to give yourself time to think. So I'm going to start by thinking about where the potential energy of my products is and where the potential energy of my reactants is on the y-axis. So I've labeled those dotted lines now. Remember, when we are talking about an endothermic or an exothermic reaction, we are thinking about whether or not the reactants are losing energy as they become products or gaining energy as they become products. In this example, the reactants are gaining energy or absorbing energy to become products. This is an endothermic reaction. The products have more energy than the reactants, which means that energy was gained or absorbed. So does the forward reaction of the same diagram have a positive delta H or a negative delta H? Positive heat of reaction or a negative heat of reaction? If we look, to get from reactants to products on the y-axis, we have to move up. Up is positive, so we have a positive heat of reaction or a positive delta H for this reaction. The heat of reaction is represented by which letter interval on this diagram? So the heat of reaction tells me the distance or the difference between my reactant's potential energy and my product's potential energy. You can either kind of measure it for yourself at the reactants line, at the products line, or you can even just notice interval C represents that distance on the y-axis. True or false? Interval B represents the activation energy on this diagram. So this is the distance from the starting point, the energy of the reactants, to the peak of the activated complex should be the activation energy. So here is the peak of the activated complex, that dotted line at the very top there. That means that interval B is representing the total potential energy of the activated complex, but not the distance from the starting point, the reactant's potential energy, to the potential energy of the activated complex. So this would be false. The actual activation energy interval would be represented by this yellow space. There is no lettered interval that represents that region on this diagram. Let's try another one. Is this forward reaction endothermic or exothermic? Hopefully, you notice the potential energy of the reactants is this middle line here. The potential energy of the products is this bottom line, meaning that reactants are losing or releasing energy to become products. So this is an exothermic reaction. Now consider, does the forward reaction have a positive delta H or a negative delta H, positive or negative heat of reaction? The forward reaction would have a negative delta H or a negative heat of reaction because to get from reactants to products, we were moving down on the y-axis. We were losing potential energy. True or false? Interval B represents activation energy of the forward reaction. So again, the distance from the energy of the reactants to the peak of the activated complex is the activation energy. So the potential energy of the activated complex is represented by the top dotted line, which means that B is the activation energy. This was true. Let's try something a little more interesting. So we've got a potential energy diagram. We've got reactants, an activated complex. I want to start with this top question. Which interval represents the activation energy of the forward reaction? So the forward reaction is moving from left to right, forward reaction. So I'm just going to look at interval 5 here, the distance from the potential energy of the reactants to the potential energy of the activated complex. That would be my forward reaction. Let's try a challenge. What would be the activation energy of this reaction in reverse if we were going from products to reactants? For the reverse reaction, this is a little funky, but bear with me here. If you are thinking about the activation energy of a reverse reaction, some reactions are reversible, which means that they can be reversed with enough energy. The activation energy of the reverse reaction is literally just going in the opposite direction from products back towards reactants. So the activation energy would be the distance from the potential energy of the products to the peak of that activated complex. So interval 5 represents the activation energy of the forward reaction. Interval 3 represents the activation energy of the reverse reaction. Pause the video. I'm going to quickly just reveal each of these answers, and you can get a sense of how you are doing on these types of questions. So pause the video, unpause when you're ready. So this reaction, if we're looking at the forward reaction, is endothermic. The forward reaction has a positive heat of reaction or a positive delta H. The potential energy of the activated complex is represented by interval 3, and the heat of reaction is represented by interval 4. Which arrow represents the activation energy of the forward reaction? This would be interval B. And finally, which numbered interval represents the heat of reaction? This would be interval 2, the distance from the reactants to the products. Wow, that was a lot of questions. I bet you're ready for a break. Awesome job. Make sure to note down any questions that you had trouble with so that you can ask your teacher or seek out another help resource to try and clarify what you're confused about. See you next time.